We left off the story of antidiuretic hormone when it was just kind of secreted into the blood vessels of the posterior pituitary. So it was just kind of synthesized, just made. It's a little hormone, and ADH was on its way to different parts of the body. So let's just pick up the story right there and figure out where does it go next. So this little molecule is, we said, a small peptide hormone made up of amino acids, and so I'm just going to draw it here. And this little hormone is going to go off to do a couple of important things. So we know at the end of the day it really wants to increase blood pressure. So one of the places it visits is all of the vessels of the body, all the arterial vessels of the body, and specifically it targets smooth muscle. So this hormone is going to go and get the smooth muscle to constrict. And we know that when smooth muscles constrict, the blood vessels are actually going to tighten down, and we call that vasoconstriction. So the blood vessels are going to get tight and small, and that's going to increase resistance. And increased resistance is going to relate to blood pressure. And we'll talk about how. We know that there's that formula. I'm going to write it over here. Delta P equals flow, Q is flow, times resistance is R. And you can actually change that around to say arterial pressure minus venous pressure equals, and we know that flow is actually stroke volume times heart rate. And it's all multiplied by resistance. So if you look at this, and if we assume for the moment that the venous pressure is going to be basically unchanged, then anything that increases the resistance over here is going to increase our pressure over here. So that's why, in this case, if ADH is able to cause constriction of the blood vessels and increase resistance, our pressure would go up as well. So that's actually one of the things that it does. And the other thing that it does is it's going to act on the kidney, right? So it's going to have an effect on the kidney. Here's my kidney. And specifically what it's going to do is it's going to cause increased reabsorption of water. So increased reabsorption of water is going to increase our stroke volume. So now you can see the other key effect it's going to have. If it's going to cause your stroke volume to go up, then just as before, now you have an increased stroke volume, so your arterial pressure is going to go up, maybe doubly up. So it's going to cause the blood pressure to go up for a couple different reasons. Now let's explore this second point in a little bit more detail, the whole idea of how it causes the stroke volume to go up. So for that, what I want to do is I'm actually going to create a little bit of space, and I'm going to draw out again, as I've done before, the efferent and afferent arterial. So we know that blood is going to enter the kidneys, and it's going to kind of do this twisting on itself in the glomerulus. And so this is our little glomerulus. And there's the proximal convoluted tubule, and there's the loop of Henle, and this is the distal convoluted tubule, and finally the collecting duct, right? So we know that this is kind of basically what the nephron looks like. And I haven't labeled all the parts, but I'm going to label the important part, which is this part right here. So this area here is the collecting duct, and what I'm circling in blue is what the ADH is actually going to work on. It's going to work on this area, the collecting duct. So it's going to have its effect here specifically. And let me try to draw this a little bit larger so we can see exactly what goes on. So let's imagine that you have, let's say, one cell there, and here's another cell here, something like that. And you have a blood vessel going alongside of it. Now, we haven't actually talked about this before, but down in here, actually let me switch colors for a moment. We have urine going this way, and blood going this way. So already, you might be a little surprised. You're thinking, well, why is blood going up and urine going down? That makes no sense. Now think about this. Before, when we were talking about blood and urine flowing other parts of the nephron, we were kind of separating out the nephron, talking about this top bit. So we were talking about kind of this top bit here. And in here, the concentration is around 300. And actually, the units on that, I'll just write the units up here, are milliosms. So it was around 300, but if you go deeper, it's about 600. And then if you go deeper than that, it's about 900. And if you go down here, it's about 1200. So what's happening as you go deeper is that it's basically getting more and more salty, right? It's getting very salty. I'll actually write that sideways. Very salty as you go down. And that saltiness is really, really important because what it does is it allows us to concentrate our urine. And you'll see why I say that. So keep that saltiness in mind, and the fact that there's this big gradient. And I'm going to actually just assume right now that we're talking about something, let's say at the 900 level. So we're at this point, kind of right here, 900 milliosms. All right? So we've got a pretty salty area out here. Now, as I said, urine is flowing through, and in these collecting duct cells, we have something called an aquaporin that basically sits like this. Let me actually show you what it would look like. So these areas are not going to allow water to go through. That's actually the first point that I want to make. Water cannot go through these areas, except for when there's a little aquaporin channel. And I'm drawing the channels for you. But you can see they're not on the surface, right? So there's no way that water, if water is sitting over here, there's no way that it can actually get through. It would actually just bounce off because it's not able to permeate the cell. It can't actually get in. So water just kind of bounces back and basically goes down into the urine. Now, what ADH does, and this is the neat thing, so ADH, what it'll do is it will float up. So ADH is actually going to float through the blood, right? Because we said that ADH is going to be all over the body. So this little molecule is going to go through and float by this collecting duct cell, and it's going to have an effect on it. So it's going to have an effect on this collecting duct cell. What it's going to do exactly is it's going to make those little aquaporins. Let me write that out, actually. This is an aquaporin. And you can see that's a really easy word to remember because it's literally aqua, meaning water, making a pore for water. So this aquaporin vesicle is actually going to merge with the wall. It's actually going to merge with the wall like that. So let me actually erase a little bit and show you what would happen. So now you have, instead of this aquaporin sitting out here, you literally have little channels that are now fused in with the wall. So you can see how those little vesicles just bumped right into the wall and fused into it. And now water is going to get a free ride across. It's going to be able to just go right through that channel, just like that, boop, and into the blood. And it's going to do it again here, and it's going to go here. So all this water is just gushing in to the blood. Look at all this water. And so this blood is going to be loaded with water now, something that it did not have before because the water couldn't get across before. And so this blood is going to go up, loaded with water, because of the ADH. The ADH basically allowed all that water to finally get across, and the blood is now full of water. And so now you can see how the volume of blood is going to go up. And if the volume of blood goes up, it's going to create a larger stroke volume for the heart. So that's specifically how the stroke volume goes up.